Okay, yesterday I put together a video for you guys called Calculating Net Force. And I realized at the end of the video and putting it together that maybe some of the explanation with the arrows moving against each other representing forces wasn't very clear in regard to some of the way we spliced the video together. And so yesterday we used this box to indicate how different arrows represent the magnitude or the strength of different forces when they oppose each other or go together, such as this one that's 17 newtons and this opposing force of 36 newtons. Obviously the box would be moving this way, but we would have some resisting forces trying to overcome the force of the box being moved. A lot of times we see these overcoming forces as friction. That's why friction will slow a ball down if it comes to rest along the ground when it's rolling or something like that. So I want to move to a clip that I want to make now that essentially talks more about these arrows and the magnitudes and how these forces work together to gain net forces or to show net forces in the end. So if you'll continue to watch, this will be a short clip kind of going over that in a little more detail. Okay, so here we are looking at some different arrows. They're all pointing to the right, which essentially means that the force of the motion is going right. But we're actually going to reverse some of these arrows and move them around and do some things to kind of show how they work with each other. Now if you notice, the arrows represent different sizes because the magnitude or the strength of the arrow is represented by the size. You'll also see the N next to the number, which represents newtons. Now we always use newtons to represent the force an object has, just as meters would measure length or grams would measure mass, or volume might be measured in liters. And so we use the word newtons to measure the force of an object. And that name essentially came from Sir Isaac Newton because he is the one that essentially came up with the three laws of motion that we use in physics. And so if you want to think about how much 1 newton would weigh if we were considered a force to be a weight of something, we essentially say a newton is approximately the weight of an average-sized apple, which again goes back to the story about Newton getting hit in the head with an apple while sitting underneath an apple tree, and kind of got his thinking going about why did the apple fall down and not up. So anyway, that's where we get the word newton from. It really is kilograms times meters per second squared is where the actual unit comes from, which is a little more in depth in middle school than we want to get to right now, but that's really essentially the unit that we are using. And so let's kind of look at how these work together. So let's say that I want to get a 10 newton force, okay? Now obviously if I want this force to stop, I need an opposing force to equal it. So if I take 10 newtons and I bring it down, a minute, trying to get this straightened out. So if I take another 10 newton force and I move it down, if I keep it going in the same direction, that now means I have 20 newtons moving to the right, okay? So one way I could easily oppose this is just to rotate my arrow and point it towards itself. And then we basically end up with a net force of 10 minus 10 because they are going against each other, so I have a 0 net force. Okay, so a 0 net force. Now, another way we could have done this was we could have kept the 10, this one here, redo that, delete that. Bring another 10 down. And if I wanted to just make one arrow, if you notice this magnitude is bigger, it's basically twice the size of a 10 newton force. If I would reverse that, then basically I got 10, this 10, plus this 10, so that equals 20 newtons. But I also have this force here moving to the left at 20 newtons. So it's essentially the same thing. 20 minus 20 equals 0 newtons, okay, or 0 net force. Okay, so 0 net force. So we can work this all sorts of ways. A lot of times when we have an object rolling on the ground or moving across a surface, it is actually experiencing friction, which is an opposing force. So opposing forces subtract each other. and like forces are added together. Okay, let's say for instance I take 75 newtons and I add another 10 newtons to it. So they're both moving in the same direction. Okay, so they're kind of assisting each other. So what I would end up with is 75 newtons plus 10 newtons. So I end up with 85 net force. And that's moving to the right. Okay? So now then, let's say that I take a 50 newton force and I reverse it, so I spin it around. So it's opposing these forces, okay? So what do I do now? Well, I had 85 newtons moving to the right, now I have 50 newtons moving to the left, so I have to subtract this 50 newtons from the net force, okay? So it's going to go to the left, and so 85 minus the 50 is 35 newtons. That's my net force. But we also have to think about what's happening here. Well, which force was the stronger force? Well, these two forces together are over 50 newtons. So in this 35 newtons, the object would still be moving to the right. Anytime we have motion, if you have a net force that's greater than 0, then you have an unbalanced force. If the net forces are 0, if basically they come together and cancel each other out, then they would also be a balanced force because there is no moving. So let's take a look at a concept such as that. So as we go through here and erase what we've worked on here, let's try to see that in action. So let's take this 100 newton force, and let's say we want to counteract that. So let's take 50 newtons here. Let's go ahead and turn it. So we got 50 going the opposite direction. Right now, in this situation, the object would be moving to the right at 50 newtons because 100 minus 50 would be 50. Because 100 is greater, it's still moving, but with only half the force because it's being opposed by half. So if I take this one now and I reverse it, now I've got 100 newtons moving to the left and I've got 100 newtons moving to the right. So basically this guy right here is 100 to the right, and this guy right, these two right here combined are 100 newtons to the left. So when we subtract those, we end up with 0 net force. And because there is no net force, because everything cancels each other out, we know that this particular situation is balanced. Okay, so I hope this helps a little bit with your understanding. Just realize if we ever have a number that's greater than 0, so there's actually a number other than 0 there, then we actually have motion in the situation. That would be considered an unbalanced force. Okay, so I hope this little video presenting some of these arrows on the Smartboard helped you to better understand the concepts of net forces and how they work together or against each other. I think the biggest deal on this is to be able to calculate the net force. So if they are moving against each other, you need to subtract them. If they're moving with each other, you need to go ahead and add them together. And then realize that at the end of the net force, if you end up with 0, there is no motion, and therefore it's balanced. If you have anything other than 0, then you have an unbalanced force. Okay? We can also have, sometimes you'll see a negative net force, which means it's moving in an opposite direction. That's also considered to be a moving or unbalanced force. Okay? So I hope this helped you out. If you have any questions, feel free to leave me a comment here on YouTube or shoot me an email. You can find my website link to this YouTube channel. Feel free to email me at my school, or you may also see me in tutoring or in class if you're still having trouble. So please watch this again. If you're still having some trouble, go back and check out the Calculating Net Forces YouTube video that's posted on my channel. Anyway, we'll see you next time. Take care.